For this question, during vaporization, thermodynamic property known as quality of vapor, X is used to analyze the mixture of saturated liquid and vapor. Explain briefly the meaning of X. Okay, and give the values of X for 5 different phases. So you have 3 marks here. So you need to list up all the phases. You have saturated compressible liquid, you have saturated liquid vapor mixture, you have superheated vapor, you have saturated vapor, you have superheated vapor. Okay, and what is the value of X? Okay, so find for each of this. Okay, just list up. Okay, question number 5. Complete the following table. So this is actually a good question and it's a good exercise. So as you can see from here, how to answer this kind of question, look at the properties that are given to you. So you are given temperature, you are given pressure, you need to identify the specific volume, X and phase. So any table will do. You can use A4 or you can use A5. So if you can make a start with A4, from A4 you need to test first. Okay, from table A4, at T equals to 80 degrees Celsius, what is your P set? So from here you can identify that is it P lower or higher than P set? P given 600 kilopascal, so this will conclude your phase. Okay, so when you get your phase, you can identify which table that you're going to use. If it's a mixture, therefore specific volume okay, is equals to Vf plus X, Vfg. If it's a superheated vapor, okay, specific volume, you can find it from table. This is refrigerant, it should be from A13. Okay, so it depends. So the same goes for the second row. You are given temperature, you are given X, so definitely this is a mixture, saturated mixture. So P is P set, right? So what is the value of P set? And you can find the specific volume from equation V equals to Vf plus X, Vfg. X you are given, Vf you can get from table A4. Okay, this one is you are given temperature 18 degrees Celsius, you are given X. So what does it mean by X equals to 1? Okay, so you can get your phase here. Okay, when you get your phase, you get this. Okay, 1. Is it saturated liquid or saturated vapor? So this should be P set, right? Okay, so if this is a P set, what is your specific volume here? Okay. Question number 6. Okay, we have V1 equals to 240 liter. Okay, vessel filled with mass 1 equals to 5 kg of water at pressure equals to 175 kilopascal. Determine the temperature of the water inside the vessel. Okay, so we only have state 1. Okay. Determine temperature of the water inside the vessel. You are given pressure, so you can find table A5. Okay, so at P1 equals to 175 kilopascal, you can easily get specific volume 1 from here, V1 over mass 1. Okay, and then you can get Vf you can get Vg, and identify what is the location of your V1. Is it between Vf or V and Vg? Okay, so if it's in between, it is mixture. So if it's V1 higher than Vg, it is a superheated vapor. So your T2 depends on the state, the phase of the state. So if it's a mixture, T2 equals to Tsat. So if it's superheated vapor, T2 from table. This is okay. This is water. Table is 6. Yeah? Okay. Question number 2. Calculate the quality of the water inside the vessel. Okay. So X2 equals X. Okay. X equals to V minus Vf over Vfg. Okay. So insert the value, you will get X. Calculate volume occupied by the vapor phase inside the vessel. Volume occupied by the vapor phase. So this is the V total. So V of vapor is actually Vg equals to specific volume G mass of me. So the question is how to get mass of vapor, how to get okay, this one is actually in the table, right? You can get Vg. How to get mass of vapor? Okay, remember you have this equation. Okay, I think that's enough for the clue for you. Question number 7. Okay, you have mass equals to 1 kilogram. V1 equals to 0.09 rigid container, so the volume is constant. T1 equals to negative 40 degrees Celsius. Then heated until the pressure is P2 equals to 280 kilopascal. Determine initial pressure. So you have mass, you have volume. You can start with specific volume 1, V1 over mass. So you can get the value. You need to identify the state of state 1. So, okay, you can put properties of your table here. Table, this is refrigerant A11. Okay, so what is your VF, what is your VG? So you can identify specific volume 1, test whether it is in VF or VG, or it can be higher than Vg. So if it's a mix, then the P1 equals to Psat. So if it's a superheated vapor, P1 depends on table A13. Okay, calculate the final temperature. Okay, so volume is constant because this is a rigid container. So actually V2 equals to V1. Okay, so when you have value of V2, you have P2. You need to identify, you need to test. Okay, to get the phase. What is the phase for state number 2? You already have V1, therefore from VF and VG here, test whether it is a mixture or superheated vapor. Okay, if it's higher than VG, it's superheated vapor. If it's in between, it's a mixture. And then so your answer depends on the state. Okay, so if it's a mixture, T2 equals to Tsat. If it's superheated vapor, T2 from table A13. Okay, show the process on TV diagram. Okay, TV diagram. T specific volume here. So we have pressure. We have two pressure here, right? We assume we have two different pressure here. Okay, so you have two line. Okay, must be complete labeling. So if this is P1, this is P2. Okay, so where is your state number 1? If it's a mixture, if it's a the first one is if it's a saturated, if it's mixture, it can be somewhere around here. If it's superheated vapor, it can be somewhere around here. Okay, so you need to identify the phase first. Question number 8, we have mass equals to 5 kilogram water fills a V1 equals to 20 meter cube rigid vessel at the initial temperature equals to 30 degrees Celsius. Is then heated until P2 equals to 100 kilopascal. So it looks similar with previous one. Determine initial and final phases of water. So you can easily get V specific volume 1 here, V1 over mass. Okay, and then you can test from table. This is water, so you are given temperature from table A4. What is your VF and VG? So you can identify what is your V1. Okay, or V1 is higher than VG. Okay, the same process. Is it a mixture or is it a superheated vapor? Okay, calculate the quality of X water if it's in a mixture phase. So if it's a mixture phase, you need to find quality X equals to V1 minus Vf over Vg. Okay. Next, determine the initial pressure. So if you have if you is mixture, P1 equals to P set. If it's superheated vapor, P1 you can get from table A6. Okay. Show the process, the same process, P specific volume. You are having two pressure here. Okay, two line. The same process. If it's a mixture in the beginning, this is P1, this is P2. If it's mixture, somewhere around here. If it's superheated region, it must be outside, but it must be on the line. Okay, P2 depends on the state or phase that you have concluded in here. Okay, that's all.